Okay, all right. So as I was saying, recommendation system ranks the second use case, the most common use case I've seen so far in Zilliz for the past 4 months. So Smart News is a a news app based in Japan, right? And so what do they do with on Zilliz Cloud, right? So they actually capture all the different actions that their news reader take, right? And based on that, they'll be able to predict, what's the most likely advertisement they will be clicking, they'll be, buying from actually, right? So this is based on what they call, or rather not what they call, but more like there's a self-attention sequential recommendation deep learning model, right? So they pass in all those past interactions of the users, and then they throw it into this deep learning model. They get the vectors, and with the vectors, they'll be able to search, okay, which is the most relevant ad with the highest possibility of click-through rate, right? So that's on recommendation system. A lot more actually I can share. Last one I want to share here will be image similarity search. So me and my counterpart, we spoke to quite a few ISVs, right? And some of them, they want to do, anti-fraud, a kind of a system where, during an eKYC process, let's say a person used another, or rather a malicious person used maybe perm face for face, right? For eKYC onboarding, right? They'll be able to detect that in real time, right? That, hey, this is a duplicate and this is likely a fraud, right? So in a recent POC I did with them, I believe it's based in Indonesia, right? And we managed to detect more than 80% of the actual fraud, right? So in October they had 94 fraud cases, and majority of them with Zilliz, we are able to detect that, right? So long story short, Zilliz Cloud is not just for RG, right? So there's a lot more use cases that you can unlock with unstructured data, with embeddings, and with Zilliz as well, and Milvus, right? Oh, but I want to share one more. So one more that I personally I feel that is very interesting. There's this company called Beethoven AI, right? Beat as in BEAT, right? Beethoven AI. So they allow you to generate royalty-free music, right? Based on prompts. You can say, hey, generate a lo-fi music, that I want to use in a cafe. Just put in the prompt. They take the prompt, they throw it into a CLIP model, which is a contrastive learning, CLAP model, contrastive learning audio pre-trained model, right? So with a prompt, they convert into vectors, they find the relevant, audio clips or the instruments, whatever, then they compose the music for you, which is royalty free. And all these use cases that I've mentioned, are some use cases that a lot of people didn't think of, right, when they think about, vector database. Okay. Now, enough talk, right? So let me show you a quick demo of a deep searcher with Bedrock and Zilliz. So deep searcher, again, you can easily find that. Search for Zilliz deep searcher on Google, you can find that. Deep searcher, it's a project that we released recently, right? It's more like a multi-agent research assistant for you, right? So we know that now with Amazon Nova being released, it has very good reasoning capabilities, right? You'll be able to, find out, the right questions to ask, because the most difficult part in every research is, well, what is the right question to ask, right? And especially more difficult when you're not familiar with the topic. For example, deep learning or BERT or embeddings, right? So we want to leverage Nova to identify, what are the right questions to ask. And then we also want to leverage Zilliz, where we store our reliable data, right? Because we know that deep learning models or even your GPT models, right, those are trained on a training set that may be outdated. It could be 2024, 2023, and it may not have your proprietary data, right? So it's important that you have your proprietary data in Zilliz Cloud, Milvus, or some other vector database, to do semantic search, right? And of course, with text, a lot of text, with a lot of research paper, how do we understand them? Now, again, we are using Bedrock to use the embedding model to convert the text to vectors, right? So then we can do the search, right? So we talk about Nova, we talk about Zilliz Cloud, we talk about embedding model, and of course, last but not least, S3. That's where we store all our unstructured data, right? The last time I did a live demo, it didn't go that well, so I hope today it works. All right. So here, right, so we have this terminal. Let me just clear the screen. So we are trying to ask, deep searcher, what are embeddings, right? So now when I press enter, right, what happens is that Amazon Nova will be generating a set of questions that I should be asking, right? So what is the purpose of embeddings in data processing and analysis, right? What are common algorithms or techniques to create? So these are questions that someone may not be able to come up with off the cuff, right? So Nova actually helped me with that. I've actually outsourced my thinking, right, to Nova actually, right? Now, for each of the question, I'm searching my knowledge base, which is Zilliz Cloud, right? What are the relevant research paper that I can ground my report on, right? So it's using semantic search. Basically, it takes my question, throw it into the embedding model, which is Python v2, right? And with the vectors, I can search the Zilliz Cloud for the relevant research paper. Then I retrieve the chunks out, right? So it's still thinking, it's still generating, more contents to, to read, to comprehend, right? Give it a bit of time.
Are these just PDFs, like research papers or something?
Yep, PDFs. So good question, right? So I actually sort of done a bit of pre-processing, right? So the question was that are all those like PDFs? So what I did previously was that I put all those PDFs into S3 first, and I converted them into vectors and store it in Zilliz Cloud. Yep. Yep, that's good. So I got all my content, but then next I have another agent. Again, it's outsourcing its thinking ability to Nova, right? It's asking Nova, hey, can you reflect on my search results? Do they make sense? Are there any gaps, right? So Nova again helped me with that. And then lastly, my last agent generated this report, right? So let's take a look at the report that was just generated, right? So this was just generated. That's great, right? So Nova actually created this XKey art diagram for me, right? So basically, it's telling me that, hey, I asked, what are embeddings, right? So this is the diagram that I created. So you have real-world unstructured data, right? You want to be able to capture the meaning, the semantics, the relationship. How do you do that? But you have to, sort of pre-process them, as I mentioned just now. Put it through a embedding model, and then you get your vectors out, right? So yeah, feel free to play around with this if you are familiar with Python, right? And again, you can search for this easily, Zilliz deep searcher, right?
Are you using any framework for this multi-agent orchestration and collaboration?
Again, what's the question?
You are using multiple agents here.
Yep.
How
That's another good question. So the question is that, am I using any framework, right? So for now, we are not using any framework. It's just pure Python with the prompts in the classes for now. Yeah, but for sure, as we scale, we definitely welcome any improvements to this project, right? So personally, for me, I've contributed this part here, right? The support for Titan, text embeddings, right? But feel free to contribute. Yep. All right. So that's the demo, right? But now let's dive deep into what's vector search, right? What are embeddings, right? Personally, for me, when I first started, I was a data scientist with GIC in 2020, I believe, right? When I came across, word-to-vec embeddings, right? So it's kind of elusive to me, right? It's neither the input to my system, it's neither the output as well. It's something that is in between these two, right? So what exactly is our embeddings, right? So we should take a step back and understand where did embeddings come from, right? So embeddings were actually, an output of word2vec, right? Kind of a paper, right? So that was in 2013. So word2vec was released, and then a lot of people realized that, hey, I can represent a word in terms of numbers, and with that, I can actually do a lot of arithmetic operations. For example, is this word similar to the other word, right? And then something happened in 2017, right? So Transformer, which is not the one from Cybertron, right? It's the one from Google, right? So Transformer paper was released, and they actually released a very important concept called the self-attention, right? How does it work, right? So given a sequence of words, which is your sentence, right? Within a sentence, for each word, you'll be able to you'll be able to learn. You can learn, what other words are more important when I'm looking at this word, right? For example, the canonical, example will be the cat sat on the mat, right? So when I look at the word cat, I know I need to be looking at sat and also the mat, right? So it's able to capture the relationship between words and the context around as well. So this means that now my embeddings is able to capture the context, the semantics, right, the relationship between words as well. And now now embeddings is becoming more and more powerful, right? And then in 2018, someone released this ULM fit paper as well. This is more of a paper on the transfer learning. And this means that with this paper, it means that there's a new technique without doing extensive pre-training. Now I can transfer this model to another domain, right? And the rest is history. Right? From then on, that's where we got a lot of models, GPT, BERT, Elmo, things like this, right? So, and then led to this point here, right? So what exactly are embeddings? As I mentioned, embeddings is really the intermediate output of those deep learning models, right? So for example, for BERT, you can actually take the last four output layers, the output for the last four layers, you can average them, and that can be, embedding of the sentence, right? Which means that you can represent a sentence in terms of floating point numbers, right? And then, this is very, this is kind of, important because with the embeddings, now you can sort of map all these embeddings into embedding space, do a lot of similarity search, comparisons, and things like this, right? So not just text, right? We were all talking about text now. There's also, embedding models for image. As I mentioned earlier, there is like a clip, right? So contrastive learning, image pre-trained models. There is, audio as well. I mentioned earlier, there is a CLAP, right? So contrastive learning, audio pre-trained models as well. So there's a lot of, different modalities and also in the multimodal, embedding models as well, right? Now, take a look at this tweet. So someone actually mentioned, so there was this question on Twitter, right? So how do you actually store vector embeddings, right? So someone actually replied that, hey, you can actually just store it on, your main memory. Just use NumPy array, right? But he forgot to ask this question, right? Or ask these questions, right? So can my vectors fit in my memory, right? So even though I'm using files, but can all my vectors and the vector index fit in my memory? That's one of the first few questions, right? And how do I search for millions or billions of embeddings in real time? Is it possible? Right? Can I achieve a sub-second or even a 10 millisecond latency? Right? How do I dynamically update, insert, doing all those CRUD operations on my vectors? Is it possible on main memory? And a lot more questions, right, to ask, right? And you have answered all these questions, you have solved all these, you probably have built something like Milvus, right? Now, next question to ask is that, hey, then why can't I use PG vector? Why can't I use a traditional, vector data, traditional RDBMS which has support for vector, right? Now, they were actually built for exact search, right? By exact search, I mean, given a condition, given a range, given a primary key, I want to get, a row out or range of rows out, right? So that is called exact search. But traditional database, they kind of don't have the ability to do semantic search, right? You could be searching for apple, right? So, there's a fruit apple, there's a company apple, right? Or you could be searching for rising dough, right? And proving red is actually the same, it has the same meaning, right? You could be asking, change car tire. But one, you could be asking like, how do I change? Or you could be asking, when do I change the car tire, right? So semantics, is very important, right? Doing a semantic search is very important, and traditional database is not able to do that, right? And most importantly, this is this data, this statistics is based on a report by IDC. So 80% of 80% of the generated data in 2025 will be unstructured, right? So that based on this report is like total amount of data will be 175 zettabytes, right? So you can do your math. That's a lot. And it makes a lot of sense to me, right? I think it makes a lot of sense because when you're doing onboarding, as I mentioned earlier, right, that's unstructured data, right? sending a picture of your face, right? When you are sending a new offer with a new company, that is unstructured data again, right? When you are sending an NDA to a customer, that's unstructured data. So it makes a lot of sense that, majority of data is 80, I mean, it's unstructured data. But at the same time, Deloitte found that 18% of the companies that they survey, they leverage unstructured data, right? So this is where we believe the opportunity is in as well, right? So there's a lot of untapped insights for unstructured data that you can leverage, right, to power your your new feature or your company, right? Now, a bit of numbers here. So the largest instance that we have seen so far on Milvus and Zilliz is a 10 billion vector on a single cluster, right? And then, one of the largest deployment on Kubernetes across multiple, instance, that will be 100 billion vectors as well. So that's something that Zilliz can handle very well, right? Now, let's dive into the meat of a vector database. How do they work, right? So you have your unstructured data, can be documents, can be NDA, can be offer letter, can be images, can be audio. All those can be converted into vectors, right? By doing that, you'll be able to, perform search on them later on, right? So that's the first step. You convert your unstructured data into vectors, okay? Now, you got to store them in a vector database. And next, let's say now I want to perform a query. For example, I'm doing this eKYC real-time, or rather real-time anti-fraud app, right? I'm submitting a photo through eKYC, onboarding process. And then now I want to check whether this face exists in the vector database or not, right? So this can be done in real time. How does it work? So Zilliz Cloud will allow you to perform ANN, right? So approximate nearest neighbor, that is the fundamental concept that underpins a vector database, right? Instead of doing exact searching by brute force each and every one of the billion, vector data points that you have, I'm doing an approximate nearest neighbor search, okay? And last but not least, you get the results. So that's in a nutshell, how does it work, right? Now, how does Milvus achieve, billion scale, right? Definitely, it comes from the architecture, right? So first of all, we, fully, adopt the open source approach when it comes to our components, right? When it comes to our own vector search engine as well, right? So, these are the components that we use in Milvus. Now, this is the high-level architecture diagram, right? So you can see kind of busy here, but a few things, right? So number one, we have a decoupled storage layer, right? So this means cost efficiency. We have a separation of concerns, right? I have query nodes, I have data nodes, I have indexing nodes. This means that when I do indexing, it doesn't impact my live workloads, okay? Right? Now, this can be run on Kubernetes definitely. And, Milvus, it's completely stateless. You can easily scale up and down on, Kubernetes, right? Now, we were talking about brute force search, right? So that's how it works. You have a query, right? And then you can search for the similar vectors one by one. Okay, so this is the brute force way, right? But what happens when you have millions of vectors, you have billions of vectors? This is where vector indexing strategies come in, right? So this is how we kind of implement a new data structure so that you can search more efficiently, right? So these are the different vector indexes that we support today. So we support flats, we support IVF flats as well, quantized indexing algorithms, we support scan, graph-based, disk-based indexing as well, even GPUs, which is CUDA enabled, right? So this is the full set of indexes that we support on Milvus, right? Now, the truth is, it's very hard to make a choice. Yep. So given so many different indexing algorithms, right? How do you choose the right one? And what is the trade-off, right? So this is something I created to kind of summarize the different trade-offs you'll be making. For example, if it's IVF flat, it's actually a clustering-based algorithm, right? So given that you have a billion vectors, first, during the indexing building phase, you cluster them, right, into multiple clusters. Then you assign centroids. right? So now when you search, you don't search all, you only search the centroids of the cluster, right? So it makes sense, right? So it becomes much faster when you search. But by doing this, what are you giving up? You are giving up a lot of throughput, right? And of course, then you say, oh, I want to improve my throughput. Let me use a quantized version of it. And then you'll be sacrificing accuracy, right? But let's say I want a better accuracy, then you'll be sacrificing your cost. You need more RAM, right? So there doesn't seem to be a perfect index to for use case, right? So this is a good segue to my top 5 favorite features of Zilliz Cloud, right? So first one, number one, Zilliz Cloud, we have cardinal indexing engine. So this allows the customer to choose just one index called auto index. Okay. So instead of having the headache of choosing and making very hard trade-off, now you can choose auto index and you will be able to choose or rather balance recall performance at query time by adjusting just one parameter, right? Remember just now there were so many indexes. For each index, they actually have their own parameters you need to select. You need to understand how it works. You need to choose the right index. You need to choose the right parameter. So all those is kind of abstracted away with auto index, right? And when it comes to performance, this is actually an open source benchmark called ANN benchmark. You can search for that again. Cardinal ranks, one of the top, or rather the top in terms of performance and recall rate, right? So if the chart is closer to the top right, it means better, right? Again, we did a benchmark of Zilliz versus Milvus. We see much better, 10 times more QPS when compared to Milvus. Okay, so that's number one. Number two, we talked about full text search earlier just now, right? So full text search, given like it's more like a lexical search instead of dense vector search, right? So by lexical, I mean that you are doing exact word matching to get the relevant info out instead of vectors, right? But how do you do that, right? You got to first tokenize your sentence. And sometimes love can be represented in different ways. Can be loving, can be loved, past tense, can be present tense. So tokenizer will take care of that. Analyzer will look at that and then tokenize the words to the right form, right? And then next you got to calculate the statistics, right? The global term distribution statistics of the words across the documents. And then you got to insert the index as well. So all this heavy lifting is actually done by Zilliz Cloud, right? So instead of implementing this yourself, right now you put in a text field, okay, and then you just map it to your sparse vector field, right? And then just say that, hey, I want to use BM25, right? So we'll do all this heavy lifting for you, and when you search, you just search with the text as well. Okay, so now this is very powerful, and this brings me to the next favorite feature, right? So with semantic search and with lexical search, if you combine them both, it has been proven that if you combine them both, you get much better recall, right, from the graph here. So you can see the triangle, it's the vector search, which is the dense search. Square is by combining keyword search and dense vector search. And lastly, if you have a re-ranking algorithm, you can even push the percentage of queries, or rather the right information. You can actually push the right, you'll be able to get more relevant information out from a vector database, right? So there's an example on the right side. So with just sparse search, right, you can only get this, you can get a lot more, right, as compared to dense vector search. So this means that full text search combined with dense vector search, it's really powerful, right? Now on Zilliz Cloud, you just need one API call, and it's possible to do dense plus sparse vector search along with re-ranking, right? So that's something I feel that's really powerful, just one API call, right? Fourth favorite feature, beyond OC, right? So this is something that we released recently. There's a lot of financial institutes, they are kind of concerned about data being with the vendor, right? So here, Zilliz Cloud supports BIOC on AWS, which means your Milvus clusters will be deployed on AWS, your own AWS VPC. Okay, so especially for the government sector as well, it's very important, right? So they have in Singapore we have GCC, right? That on GCC they have different compartments as well, right? They require vendors to deploy the data clusters in the VPC, their own VPC, right? So right now, Zilliz Cloud, I believe, is the only vector database with bring your own VPC feature today. Okay. Last but not least, I feel that this is one of my favorite as well, which is embedding generation, right? We talk about, converting your text into vectors, and then you have the headache, how do I maintain the pipeline? How should I schedule this? How often should I run this? What happens if this pipeline doesn't work? So now this is coming soon. This feature will be released on Zilliz Cloud in Q2, right? So this means that now you just have to put in your text, right? And then you provide the secrets. For example, you are using Claude, or you could be using Amazon, Amazon Titan, right? Text embedding model. Put in the secrets, and then we will handle the embedding for you, right? It's the same way as full text search, right? So you just have to map your text field with your dense vector field, and then specify your API key, right? So this part, the embedding generation, will be handled by Zilliz Cloud in the near future, right? So that kind of concludes my top 5 favorite features of Zilliz Cloud, right? In a nutshell, with Zilliz Cloud, you'll be able to greatly reduce the infra costs because of the better performance, right? So with the same resource, you can have much better performance, right? And of course, being a fully managed service, we handle all the day 1 and day 2 operations for you, right? And of course, we do have SLA guarantees on our services, right? So Zilliz is available on AWS Marketplace. You can search for that on Marketplace. Either that or you can scan it right now. Sign up for Zilliz Cloud account. So quick note, so right now you don't have to put in any payment information. You get a free $100 credit right now. Like just takes seconds to create, right? And thereafter, if you link it to AWS Marketplace, you get another $100. So total $200 for you to play around, right? With. Okay, so a quick summary of what we have discussed so far. So with Peng Fei sharing about the bedrock, that really forms, like no pun intended, the bedrock of your Gen AI and your AI applications, right? So it provides you with great foundation models. There's embedding models that Zilliz work very well with, right? There are built-in knowledge bases, right? You can easily build agents on Bedrock as well. And VeloDB, that kind of forms, or rather, that is the lake house that for your structured data, right? So VeloDB, it provides you the ability to do federated queries, right? You can actually query all your open formats as well, like Iceberg, Delta Lake, Hoodie as well, right? So that forms a great lakehouse solution on AWS. As for the 80% of your data that's unstructured, Zilliz and Milvus will allow you to search all those unstructured data, power semantic search, all those use cases I talk about, right? And that kind of allows you to tap on the power of those 80% of data that you're not using today, right? And of course, WillOps, interestingly, I just found that Zilliz Cloud uses Dolphin Scheduler under the hood for cluster creation, for cluster updates. Unfortunately, William is not around to hear that. I thought he would be happy to hear that, but not just Dolphin Scheduler, for our migration tool, right? Today we allow migration from Elasticsearch, Pinecone, and a lot more. I can't remember all. That is actually powered by Apache cTurner. Again, it's an open source project by William, right? So WillOps is really the glue, right, for us, right? And of course, S3, not to mention that. Okay, so I hope you find my presentation helpful, right? We're definitely happy to stay connected. You can scan this QR code to connect with me. Feel free to reach out to me and my friend there, Rufus, if you have any questions on Zilliz Cloud. Right, thank you so much.